Okay, we'll try to look at some few examples where I have to determine the convergence of some given series, and it's not really um, the questions that we are going to have is that it's not really specified which test that we are supposed to apply in order to determine the convergence of that given series. It's just up to us to be aware of when we are supposed to use the integral test, the limit comparison test, the direct comparison test, the ratio test, the root test, as well as knowing what kind of series that we are. Is it an alternating series? Is it a geometric series? Is it a P series? Is it a harmonic series? So if we have all that information, it becomes much easier to deal with some questions. Okay, because in as much as you can manage, for example, to work out a question that where you're supposed to apply the ratio test, you manage to do it using the integral test. It might take you a lot of time compared to if you are to use the ratio test instead of the integral test. So it's very important that we remember and we understand the formats. In terms of which type of test that we are supposed to apply. So the first example that we are going to go through is let's say we have a series, okay, that has the lower bound of n from 1 to positive infinity. And let's say our a sub n is minus 1 to the power n plus 1, okay, then multiply by 2 to the power n divided by n factorial. So before even going any further, I understand to say this is an alternating series. Okay, it's an alternating series, and I just have to know how to deal with an alternating series. How do I go about determining the convergence of an alternating series? Okay, so once again, just remind ourselves, an alternating series is the one that is in that form where you have negative 1 to the power n plus 1, as well as in some cases where you have negative 1 to the power n. So what do we mean by having an alternating series? If I give myself a sequence of numbers such as 1, 2, 3, 4, 5, 6, 7. So you observe to say what we have here is a sequence. Okay, if I were to make this as a series, let me say this is a plus, minus, plus, minus, plus, and a minus. So you observe that the sign is changing. Okay, your sign is changing. And how does your sign change? Your sign changes in respect to what? In respect to the n. Okay, so in terms of this one here that we have, you observe to say if n is equals to 1, okay, if n is equals to 1, meaning you are going to add the 1, okay, to make it a 2. So negative 1 to the power 2, that is a positive. So you see that the sign is going to be what? The sign is going to be positive. But for the second one, the sign is going to be negative. But that is in respect to some other series that we might work with, not necessarily this one. I was just trying to show that you have a positive, negative, positive, negative, positive, and a negative there, and the pattern keeps on going. So that's what it means by having an alternating series. Okay, so when you see one in this form and any in that form, just want to say you are dealing with your what? You're dealing with an alternating series. So when you're dealing with an alternating series, you just have to focus your attention on this part, of which that's what you're going to name as our a sub n. Okay, so we're going to say our a sub n will be equals to 2 to the n divided by n factorial. Okay, so what I'm able to do here is that I need to apply the ratio test. Okay, I need to apply the ratio test. It's very much convenient to do work out factorials when you're dealing with when you're dealing with factorials. It's very much convenient for you to apply or to use the ratio test compared to the other test. For example, the integral test here, it might work out, but not as easy as it would be, not as easy as it would work out when you're dealing with when you apply the ratio test. Okay, so I'm just going to write our a sub n plus 1 in advance. So this is going to be 2 to the n multiplied by 2. Remember to say this is the same as 2 to the n plus 1, but I want to write it in that way because I have to do some cancelling out at some point, so it's much convenient to write it in this way. So even the n factorial, I'm going to add the 1, so I'm just going to write that n plus 1 multiplied by n factorial. What we have here, and writing it as n plus 1 factorial, is simply one and the same thing. All right. So that is what we have. That is what we have as our a sub n plus 1. So remember to say we're going to say the limit as n approaches infinity, okay, of the absolute value of a sub n plus 1 divided by a sub n. This here is our a sub n, so it will be this divided by that. Okay, so I'm just going to write that as my 2 to the n, then I have my 2 there, divided by n plus 1, then I have my n factorial. So instead of saying divide by that, I'm going to multiply by reciprocal of that. So that would be multiplied by, instead of dividing by 2 to the n divided by n factorial, that would be like multiplied by n factorial divided by 2 to the n. Okay, so we observe to say at this stage, this goes and that goes, that goes and that goes as well. So what we remain with is that we are going to have the limit as n approaches infinity of the absolute value of 2 divided by what? Divided by n plus 1. Okay, so what we have here is that this is going to be equals to 0. It's inevitably going to be equals to 0. When we substitute with infinity here, we're going to have infinity plus 1, or even just infinity 2 divided by infinity. It's still going to give us what? It's still going to give us a 0. Okay, so now we observe to say the value that we get is a 0. Okay, this is not equals to infinity, so it's just supposed to equal some value. All right, so now we don't yet make a conclusion from here. So for us to make a conclusion that this converges, we just have to we just have to ensure that our a sub n plus 1 is less than or equal to our a sub n. Okay, so it's more like, let's say for example our a sub n was equals to 1 over n, then our a sub n plus 1 is equals to 1 over n plus 1, of which we observe that this one is less than that one there. Okay, so now is our a sub n plus 1 less than our a sub n, or let me say less than or equal to? The answer is yes. Okay, if you try to replace with some values here and there, you're going to find that this one is greater than that one there, or let me say greater than or equal to that one. Okay, if you start with 0, for example, if you start with 0, let me say 2 to the power 0 is 1. Okay, then 0 factorial is still 1, so we have a 1. Then if I try to replace with a 2 here, with a 0 here, okay, with a 0, this is going to become 2 to the 0 is 1 by 2, that will give us a 2, then divide by 0 plus 1, that is something like that's a 1. Okay, that's a 1 multiplied by 0 factorial, so we get what? We get a 2. So let's just say in fact, I don't think you're supposed to pick 0. It's supposed to be some numbers greater than that value. Okay, greater than 0, some numbers greater than 0. So if we pick 1, 2 to the 1 is going to be 2, then 1 factorial is a 2 here. Okay, then if we pick a 1 here, this is going to be 2 to the 1 is 1 by 2, that is going to give us a 4. Then 1 plus 1 here, that would be a 2. That would be a 2 here. Then 1 factorial is 1, so divide by 2, that would give us a 2, so that is equals to. But if you try to replace with a 3, for example, if I say a sub 3 is equals to, that would be 2 to the third divided by 3 factorial, so this gives me 8 over 6. Okay, 8 over 6, which is simply 4 over 3. Okay, then if I say a sub 3 plus 1, that would be equals to 2 to the third multiplied by 2 divided by we say 3 plus 1, that will give us a 4. Okay, on this part. Then 3 factorial, that's a 6. So now this gives us 8 by 2, that gives us 16. Okay, this part here is 8. Okay, then on the denominator 4 times 6 is giving us 24. So this value is 0 point some value, and this one is 1 point. So we are confident to say our a sub n is greater than our a sub n plus 1, and that's when you're able to make a conclusion that what the series that you have converges. Alright, and that is when you're applying the ratio test. Okay, so now let's go to another example. Let's say we have a series of the form of course is from 1 to infinity. Then we have our a sub n, then we have our 3 over 4 here to the power n. Okay, so you observe to say this part is nothing more like 3 to the n divided by 4 to the n, of which you can apply the ratio test if you want, but I don't want to waste my time um, applying the ratio test, because what I know here is that I'm dealing with a geometric series. Okay, it's a geometric series, and here is my value of r. So we can say our r is equals to 3 over what? 3 over 4, of which this value is less than 1. And if our r is less than 1 in terms of, in fact, we say the absolute value of r for a geometric series, if we say the absolute value of r is less than 1 for a geometric series, then the geometric series that you have converges, and that's the conclusion. I don't even have to go any further. You can try to apply the ratio test, it still work out, but even at this standpoint, just being able to recognize that I'm dealing with a geometric series and my r is less than, I mean the absolute value of r is less than 1, then we can say it does what? It does converge. Okay, so let's say we have of course to infinity from n is equals to 1. Let's say we have a rational expression of n divided by n plus 1, n plus 2, then n plus what? N plus 3. So now what I'm able to apply here is the limit comparison test. Okay, so we observe to say when we expand the denominator, that's going to be quite a huge expression, but the n with the highest power to be n to the power 3, because that'd be like this n multiplied by this n by that n there. Okay, that would be n to the power 3. Hence, I just have to focus on the highest power on the denominator and the highest power on the numerator. So the highest power on the denominator is n divided by the highest power on the denominator is what? N to the power 3. That gives us what? 1 over n squared. So observe to say what you have here is nothing but a p series which converges. Why does it converge? Because the value of 2 that we have here in terms of p is greater than 1. So for your p series, if this value is greater than 1, then it converges. If it's less than 1 or equal to 1, then it diverges. Meaning if it's equals to 1, such as n or 1 over n, this we call it a harmonic series. But I like seeing a harmonic series in terms of a p series. I'll just say, okay, a harmonic series is nothing but a p series that has that is to a degree 1. All right, and that diverges and this converges. Okay, so the thing is that in as much as what we have here, this part here, of course we are going to call this as our b of n. Then what we have here is our a sub n. We have to determine what it converges to. Okay, so now it's that thing where when you're applying the limit comparison test, you find out that your b either diverges or converges. In this case, our b of n, which is our 1 over n squared, we say it converges because it's a p series. So meaning our a sub n also is going to converge, but that's only after we do something. Okay, we are yet to find out. So we're going to take the limit. We're going to take the limit as n approaches infinity. Okay, as n approaches infinity of a of n divided by uh, a of b of n, or b sub n. So here we're going to have what we have right here. That would be our n divided by n plus 1, n plus 2, n plus 3 there. Okay, so we multiply this by what? By I will multiply it by the reciprocal of b sub n. That would be my n to the power n to the power 2 divided by 1. That would give me n to the power 3. Okay, I forgot something here. That would give me limit as n approaches infinity. That would be n to the power 3 divided by n plus 1, n plus 2, then n plus what? N plus 3. So even at this point, I'm not just going to bother much about what I have on the denominator except the highest power. And the highest power that I'm having is what? Is my n to the power 3. Okay, so I'm just going to say the limit as n approaches infinity of n to the power 3 divided by n to the power 3. That gives me what? That gives me a 1. So now, the value that we find after dividing a sub n divided by b sub n, if the value is positive, okay, and it is finite, then whatever happens to b of n also happens to what? To a of n. So remember, we found that our b sub n converges. Okay, so we had to confirm that even a sub n converges. But how do we confirm? We have to divide a sub n divided by b sub n. Then the limit that we find, first of all, it has to be positive. If those two if these two conditions are fulfilled, then everything is, meaning what happens to b of n also happens to a sub n. And because b sub n converges, even this one also does what? A sub n also converges, because of what we have found here. Found that one is, of course, is positive and it is finite. If it is the other way around, then we are afraid it does what? It does converge, I mean diverge. Okay, so let's try to look at maybe one last example to try to see which test that we're supposed to apply. So let's say we are given a series of 1 over 4 to the second plus 1 over 7 to the second, or plus 1 over, let me just say 10 squared here, plus 1 over 13 squared. So first of all, we observe to say we have to come up with a formula here. We have to come up with our a sub n. Okay, we have to come up with our a sub n. Okay, so with regards to the sign does not alternate, is still positive everywhere, but the numerator remains as 1 to the observation here. Okay, it remains as 1, so we divide by, what kind of pattern are we dealing with on the denominator? So you observe to say, of course I'm going to address the n, I mean the power there later. So you observe to say, on the first one I have 4 instead of 1. Okay, I have 4 instead of 1. Then on the second one I have 7 instead of 2. So this is more like 3 times n plus what? Plus 1. So you observe to say, if I were to pick this one, which is the fourth one, if my n is equals to 4, I multiply by 3, that's 12 plus 1, that gives me a 13. So meaning I'm dealing with 3n plus 1 squared. Okay, so now what test am I able to apply here? I believe the integral test will be much convenient. Okay, so I'm going to write this as I'm going to write this like this. I'm going to say from, let's say, from 0 to infinity of 1 over uh, instead of saying 3n, I'll say 3x plus 1 squared, then dx. Okay, so here I'm able to integrate this one, and of course I'm able to apply the u substitution. I'll let my u be equals to 3x plus 1, so my du will be nothing but 3 dx. Okay, so many I can rewrite as so this is going to be 1 over u squared multiplied by dx. Our dx is du. Okay, is du divided by 3, but I can put the 1 over 3 outside here. Okay, so we can integrate the u. Okay, we can integrate the 1 over u squared, and that's going to give us something like 1, we can say 1 over 3, then that would be minus 1 over u, then limit infinity from 0. Okay, so I would want to write this back in terms of x. Okay, so I'll say let me say negative 1 over 3, then inside I have 1 over my u, I've said is what? Is 3x plus 1. Okay, from 0 to what? From 0 to infinity. So when we substitute there, you observe that this is going to be 1 over 3. Okay, so I'm going to have 1 over, of course it's negative, 3 multiplied by infinity plus 1 minus 1 over 3 multiplied by 0 plus 1, like that. So this part here gives us a 0, we know. Okay, then this part here is going to give us a 1, because 3 times 0 is 0, then we have a 1 there, so that will give us like negative 1, so that we have negative 1 over 3 multiplied by negative 1, so that gives us what? 1 over 3, and that's the value that we have, which is 1 over 3, and we're able to conclude that it does what? it does converge. And that's simply how you go about answering questions that are given. It's just a matter of knowing which test is going to apply in respect to what we have understood about all the tests that we have been doing. And once again, it's very important that you understand when you have an alternating series, when you have a harmonic series, when you have a p series, when you have a geometric series. Things are become much easier. Okay, or perhaps even a telescopic series as well. Yeah, thank you very much for watching.